your weight reading. Okay? Check the utility room fuel papers and notify the blockhouse when we're clear to start generators. Control voltage on. Gyros on. Gyro erection on. Check the box loading has been completed. Roger. Connect assembly to igniters. Okay, tie down the lead.
Here, in a few seconds, the work of many men and women will meet the supreme test.
Weight reading after last scaffold is removed. AFMCC telemeter calibration tape on. Start vibration and RPM recorders. Check all operating lights and meters for proper operation. Power panel check. Control panel check. Roger. Magic panel check.
Only a few are fortunate enough to witness the actual firing, but the skill of hand and dedication of spirit needed for a successful space vehicle launch comes from all across the land.
Power transfer test on. Observe and record.
A space rocket is more than a tower of metal and fuel. It is a responsibility of every individual who contributes to its final construction. Once a space vehicle is launched, there is no turning back. Here we can turn back. We can dig out the story behind the story. Who are the people who build a space rocket? This is Harry Reiner. Some months ago, Harry was just another applicant for a job. Past experience? Well, let's see. He drove a truck during the summers in high school. Then he served on a destroyer in the service. A couple of odd jobs around town. And oh yes, he's a ham radio operator. One thing Harry wants to explain, he has more than a passing interest in space vehicles. There's a future in this work, and Harry is a careful craftsman. This sounds fine. All right, your training will start on Monday. You will learn how to solder rocket components. Training to solder? I could always use a soldering iron. Besides, I thought they did that automatically. Oh, well, I guess they know what they're doing. Yes, Harry, they know what they're doing. And they want you to know the chemical properties of solder and rosin even before you start the job. Solder is an alloy, simply a mixture of tin and lead. But what makes this alloy so useful is a quirk of nature. Notice the melting point of solder is nearly 100 degrees lower than that of tin or lead. Here is a combination of two metals that for some reason will melt at temperatures nearly 100 degrees lower than the two metals it's made of. No one can tell you exactly why this happens. It's simply one of those unpredictable quirks of nature that the human race, without completely understanding, can harness to its own advantage. But why is this phenomenon so important to us? The answer is simple. Here is a sheet of pure lead and a rod of pure tin. Both have relatively low melting points. But through the miracle of solder, they are bonded together without the danger of melting the tin or the lead. For example, the seams of an ordinary tin can are soldered together and without damaging or melting the tin. Now let's see how solder works. Notice that on this sheet of copper, as the solder melts, it flows smoothly to form a thin, even coating. Solder is not a glue. When the copper is hot enough to melt the solder, the molten solder actually dissolved small amounts of the copper and then penetrated its surface. In this cross-sectional drawing, we can see that the molecules of the two metals have actually blended together here to form one new metal, which is part solder and part copper. This mixing of the molecules is called the wetting action. To obtain good wetting action is not always that simple. On this thoroughly clean sheet of copper, you will notice a marked difference in the reaction of the solder. it seems to ball up and not flow smoothly as it should. A cross-section would show large areas where the two metals have not blended together. The mixing of the molecules, the wetting action, has not taken place properly. In the first demonstration, the two metals are permanently fused together. Because of good wetting action, the solder is completely embedded in the copper and cannot be pried off. But the solder in the second demonstration is easily debonded from the copper. But why should good wetting action occur on one piece of copper and not on the other? The answer is simply air. When a clean metal surface is exposed to air, a chemical reaction occurs called oxidation. When heat is applied, as in the soldering operation, the oxidation is greatly speeded up and produces a non-metallic film that will prevent solder from touching the base metal. This film of oxidation makes good wetting action impossible. So even though our metal had been cleaned thoroughly beforehand, the oxides in these areas formed while we heated the copper and prevented the solder from bonding. These oxides must be removed or prevented during the solder operation. For this, we use chemicals called fluxes. There are many types of fluxes. However, only those derived from natural rosin are acceptable in soldering electrical connections. When the heat required for soldering is applied, the surface of clean metal will quickly oxidize. The flux must dissolve and remove these oxides. As you can see, the area around the flux is discolored, while beneath the flux, the metal is clean and ready to accept solder. For ease of application, solder and flux are produced in a combination called core solder. The rosin flux is contained within the solder itself. Core solders are manufactured with various core designs. With this cutaway model of cored solder, we are able to see exactly how the solder-flux combination can work together. The flux must have a melting point lower than that of solder, thus enabling the flux to reach the metal first and prepare the way for the solder. As the solder melts, it displaces the flux on the cleaned surface. Flux also helps solder flow as it should, then rises to the top and is pushed to the outer edges, carrying with it the oxides it has removed. That's even news to Douglas McMullen. He's another job seeker. He wants a job soldering. That's his specialty. He's been soldering TV sets for 10 years, a real expert. He brought his own iron with him. Fine. You'll start school on Monday. They'll teach you how to solder space vehicle components. What, says Mac, school for me? Why, I've been soldering for 10 years. I have a great right arm and my own iron. You heard what he said. School starts Monday. Space vehicle soldering is different. If you want to be an operator, you have to learn that. If you're a contractor, you have to teach it, run a school, or set up a training program. For within a space vehicle, there are thousands of soldered joints. The people who solder these joints have a responsibility far above and beyond the normal standards. The training period is not long, but they pack a lot of information in a short time. The important thing in any space vehicle soldering course is developing a careful, vigilant attitude. There are 3 things to watch. They are in this order: cleanliness, cleanliness, and cleanliness. Oh yes, one more thing, cleanliness. Mac has been soldering for 10 years. He's beginning to understand that rocket work is different. In outer space, there are no TV repair shops to correct your errors. Harry lacks experience, but he has a deep respect for any electrical joint. He is taught to visually examine the small plated board for any defects. He looks first for a smooth, even texture and appearance. Together, they're trying to find blisters or wrinkles or a possible separation of the conductor pattern. Any dirt or grease on the board is cause for rejection. Oxide is the enemy. This board is okay, so Harry prepares to solder. Just before soldering, a pencil-type eraser is used to clean the pad. When cleaning the wire, he uses 2 typewriter erasers between a staple puller. Mac, too, is gradually learning that proper tools are important. Now, Mac thinks he's all set to go. If you want to see the wrong way to go about it, watch this man of experience. He's cleaned the wires, but he puts his dirty hands all over the wire, nullifying the work. See here, the component should be centered between the 2 pads, not favoring one or the other. Look at all the space he leaves between the component and the board. A basketball player could walk under there with a high hat on. Go on, Mac, you're giving us a laugh. No, bend the wires toward the pattern. Too late. Never mind checking the temperature or cleaning your iron. Go on your merry way. That does it. You managed to do just about everything wrong. Suppose we let Harry do it the right way. Remember, the first rule is cleanliness. Once he has cleaned both the pad and the leads, Harry is careful not to touch them while preparing them for insertion through the board. He places the component midway between the 2 holes, then presses it down so it is firmly against the board. Now he carefully bends the wire using round-nosed pliers. Once through the hole, he clips it off about 1/16 to 1/8 of an inch. The wires should be bent toward the pattern. Carefully following the instructions, he uses a small brush to keep everything clean. Proper tools create proper techniques. Harry can and does regulate his temperature control depending on the size of the circuit and the leads. Once again, that word cleanliness pops up. He cleans his iron with a wet sponge. Either a wedge or a pyramid-type iron is used. It is important that the iron be the right size and shape for the work. After tinning the iron, it is cleaned again before soldering. Then he uses the specified type rosin core solder. He starts the solder flowing where the tip of the wire is cut, then moves it back. This results in just enough solder to make a good joint. There's no pileup or excess. This is a good joint, and the contour of the wire is plainly visible. It's a good thing Mac is on the stick. That's a good joint, but it should be cleaned with a little alcohol. Harry figures he should go to the head of the class, but Mac is now wise to the fact that soldering for space vehicles is different. The instructor is hard-nosed about every detail. He wants a good look. Mac says he's casing the joint. Under the lens, this one still looks good. It has that smooth and shiny appearance, and there's no excess of solder. Here's a joint that isn't any good. The dull, milky appearance indicates a cold joint. Not enough heat in the iron. This one has a crack up close by the wire. This means dirt, and no more need be said about that. By now, both students recognize that this is too much of a science to be called an art. Too much of an art to be called a science. In the next few days, they solder many different types of components. Some have irregular shapes and are difficult to mount. Transistors require heat sinks between the connection and the component. Extreme care is necessary. there can be no damage to the transistor. There are rigid specifications for each particular problem. Certain basic attitudes become good habits. Mac has learned that cleanliness pays off. He also discovers a latent skill for diagnosing the problem and selecting the proper tool. For example, these long-handled pliers. Harry discovers there are tricks in every trade, techniques to be mastered. But the real mastery lies in constant attention to detail, no let-up in good habits. Mac seems to be on familiar ground here. See how deftly he strips the piece of insulated wire? It's hard to unlearn bad habits, but the instructor is a patient man. The ordinary wire stripper frays or nicks the wire. It should never be used to strip wire for space vehicle work. Instead, a heated wire stripper is the recommended tool. It even works well for Teflon insulation in a well-ventilated room. When and if cutting-type strippers are used, they must be the exact size for the wire, calibrated daily. Next step is to clean the terminal. Mac uses a solvent and a lint-free cloth. This time he does it just right. And Harry is learning conductor wires must be tinned before soldering. In this operation, 60-40 solder is used, and cleanliness is, as always, important. Tinning should only extend far enough to take advantage of the depth of the terminal. Harry knows he is making a solder joint, not a mechanical connection. The wire is never hooked more than 180 degrees. He hooks the wire to the joint so there's no movement during the soldering operation. Because there is a lot of heat to be transferred, Harry clips a thermal shunt into place. This guards against overheating the component. Now, great care is needed. The joint should not be disturbed until the solder has cooled. The wire should be bonded directly to the terminal. In a properly soldered connection, a good guide is that the distance from the insulation to the joint is equal to the diameter of the insulated wire. Once he throws off his old habits, Mac learns things well. In soldering a wire into this miniature connector cup, he fills the cup with just enough solder. By sliding the wire slowly to the bottom of the cup, it reaches the correct temperature and prevents a cold solder joint. At the same time, slide the hot iron toward the base. This will distribute the heat uniformly and prevent gas pockets or voids. Mac soon learns that a false security is created when a wire is wrapped more than halfway around a terminal. This practice is taboo in space vehicle work. A slight J formed at the end of the wire provides ample surface and a neat configuration for soldering. This connection is just as reliable as one with twice the amount of solder and much more easily inspected. In another operation, Harry learns to use a resistance-type soldering tool. Resistance soldering affords a means of localizing the heat to a selected area, which makes it well adapted to the soldering of miniature connector cups. Harry also learns to use a tweezer-like heat dissipator to prevent wicking of solder up the wire. The foot switch is used to turn the current on and off. This gives him control of the temperature, leaving his hands free. It's all part of having the right tools to do the job. In the week-long course, both men develop an attitude of responsibility and pride in their work. They practice and perform the soldering of many different types of joints. They learn to keep their tools in efficient working order, clean and readily available. Their fingers become adept at handling the components so necessary to space vehicle work. Most of all, they learn to cherish the fundamental principles as expressed by the unbending standards of the instructor. When it comes to self-discipline, they are as tough as a combat team. Harry finds his job a means of expressing pride in his skill. Mac will never go back to TV work. The changeover was difficult, but he has a new sense of direction, and he likes the feeling. No two rookies ever left boot camp with more pride of accomplishment. In the months that passed, both Mac and Harry proved themselves on the firing line. This is no practice session. The distributor Harry is building will fly into space. Reliability of every tiny joint is the factor that can spell the difference between failure and success. A good inspector is not there to criticize and nag. His job is to improve and maintain quality standards. He must lead by being aware of the latest methods of inspection and operation. He must promote flexibility of thought, but he must be inflexible in his demands for perfection. No one ever said it was an easy job. Mac will be the first to agree with that statement. In 6 months, he was promoted to a production line inspector. Mac has the personality to handle the job. He says you can't inspect quality into a job. It has to be built in. Mac has found that leadership is best expressed in understanding, but reliability can only be achieved by the constant attention to every detail. He explains to all his operators that Cape Canaveral is only a series of details in a visible form. For success, every detail must work. And there are times when all the work is worth it.